Okay, this is the Titan Aero Gold kit that I'm going to be putting on a 3D 10 Max. And this is the empty box because I've already got all the parts out in front of me, and I've gone through the pain and the headache of figuring this out ahead of time before my final assembly, because let me tell you, I've had to print this bracket multiple times now, making adjustments and changes as need be. Thingiverse is an awesome resource for finding pretty much anything, because a lot of people have already done what you're trying to do. And in this case, it is putting a direct drive on a CR-10. In this case, I am doing a CR-10 Max, which is just a CR-10 Pro, but bigger. But anyhow, so there are some subtle differences between the CR-10 and the CR-10 Max, and changes that I had to make to this bracket that was very well thought out and very well done by the original designer, and I'll leave a link in the description. I will upload the personal bracket that I have done to, or made modifications to Thingiverse as well. Give credit to where credit is due to the original designer, and also leave a link to it. So anyhow, changes that I had to make. Number one, widening these holes to accept the carriage bracket that goes on the gimbal on the CR-10 Max. And the other changes I'll go through as I'm putting this stuff together. Now, the first thing I've done already is I have already attached the BL Touch to this. You'll see why as I assemble this, because if you don't do it first, you won't be able to put it on later. You'll have stuff in your way. Well, kind of. Really just the fan will be in your way. But anyhow, I just went ahead and did that ahead of time. And then the bracket, let's go ahead and get that started first. And the reason why, and you'll see, I have made, there's a hole in the bottom of this for this nut, and the hole is wide enough to where it catches the nut, where it's slightly loose, but for the most part it'll hold the nut in place while you're running your screw through the back side, so that you don't need a wrench to do this. But anyhow, the holes for the BL Touch bracket are going to line up with these holes, so it kind of helps with putting this in place. And you can see the nut down inside of the hole right there, and you can see that this has already been done a couple of times because it's left groove there in the anodized aluminum. Now, the standoff for your bottom pulley has got a cam on it, and you can see right here as I turn it, that cam is going to change which side of the hole it's putting pressure on. The reason why is because once all the pulleys are on here, the bottom pulley has this hexagon standoff, so you can grab it with a wrench and adjust the tension on of the pulleys on the gimbal, so that you can adjust how easily it slides, how much slop is in it, etc. So anyhow, that being said, let's go ahead and put the standoff on. Make sure the cam side is going in the hole. Alright. Now, when you're doing this, Allen wrenches, the kit does not come with good Allen wrenches. Best Allen wrenches are the ones with these little round ends on it. Oh, it makes life so much easier. So, anyhow. By the way, I am doing this with a tripod sitting between me and the equipment, so if I fumble, you know why. Go ahead and get your laughs in. Alright, now, don't tighten this up all the way. Leave this, you go ahead and snug it, and then back it off, maybe a quarter turn. Just give it a little bit of play. That way, when you go to mount this to the gimbal, you got a little bit of play in it. And you can get it square, and square would be lining these edges up perfect, whatever. But anyhow, the next change I had to make to this when I printed it was a notch for the pinout on the motor. That socket right there The original design did not have a notch, and for cable management, I want the wires to come out the top because all my wires are going to be coming out the top of this. I want these wires to come out the top for cable management's sake and to keep things clean. I wanted this to be able to pop out the top. And when you pop the motor in, the original angle got in the way of this. So simple notch I made in it. However, so that this can be printed without any supports whatsoever, I still had to keep part of the angle. So I notched this out, but at the same time, I left just a 0.5 millimeter piece on the bottom. That way this could all be printed without any supports. And yes, even with using bridge settings, got a little messy on the bottom with a little bit of threading, but not near as bad as if you try to print this without anything in here at all. If you try to print this with a notch in it completely, when the printer goes to draw a line right here, obviously it can't just let something hang in midair. It stops here, whatever, plastic just drops. So for, you know, beautiful bridge settings, you want something in there. So either way, I left a 0.5 millimeter piece in there that was easy to cut out afterwards with a box knife. So anyhow, moving forward, the motor is going to fit in here nice and snug, especially with a little bit of threading that's left on the bottom side of that roof, but no one will ever see that. It'll be hidden, and that is going to pop in nice. And ooh, I like that snap where it just snaps into place. And once again, the original designer of this did a fabulous job. All the holes line up perfect, incredible. So for assembly, we'll just let that sit right here. Now also, the gear. When you're doing this, you'll have to pop the motor in and out several times so you get the gear placement just right. But now I've already got that where it needs to be ahead of time, and I'll explain that in a moment. So here is the housing for your Aero Gold, and it's going to sit in there comfortably. I think the original design was just for a Titan Aero. I don't know how much of a difference there is between the design on the Aero Gold and the Aero, but either way, the housing fits perfect. And spacing on this. Alright. You're going to see what I was talking about with the gear spacing. But anyhow, there is a notch here for the large drive gear. And you have your shaft, which is going to sit right in there. It's got a hole all the way through it because the screw is going to run all the way through into the motor and help hold it all together. Alright, so this is what I was talking about with the gear spacing. You want it so that when the lever, which, by the way, the lever, this is where your filament feeds through, and you see they put a handy dandy little arrow there so you know which way to pull it. When it's together, you're going to pull this backwards to relieve the pressure so you can push filament in or pull filament out. And the hole here is going to go over the motor drive shaft, and it has a little wheel on it, and that little wheel goes against the actual drive gear that's going to grab the filament and push it through. And on that drive gear, you will notice these little teeth. Those little teeth is what grabs your filament and pushes it through. So considering that this right here sits on the drive shaft of the motor, you want the spacing of that gear on that drive shaft to be such that it holds the lever where the little pulley on the lever, the little wheel on the lever, is lining up with those teeth. So that's why I say you'll end up pulling that motor out and putting it back in several times until you get that gear exactly where you want it. So that being said, let me go ahead and put the drive gear back in, and if I keep the housing in place to line it all up, and then put the arm on, and my little wheel is lining up with those teeth beautifully the way it should. Now, that being said, something else to take note of. When you go to screw this down after you have it assembled and tightened, you'll notice that depending on your looseness of the case, you may have some space between your gears, just enough gap between those gears that teeth could potentially skip. So when you go to tighten this down, you want to pull the housing down a little bit so that those gears are nice and snug up against each other and there's no opportunity for them to skip. Alright, before we go putting that lever on though, this is the tensioner knob. You have a nut that will stay more or less in a fixed position. Well, the tensioner will be held in a fixed position going back and forwards with that little ring that's on it, and the nut will be held in a fixed position in such that it can go back and forth, but it can't turn because the slot that this nut will sit in has a hexagonal shape. And so when you turn this and that ring right there is held in a fixed position, it is going to force that nut to move forward or backwards. And that's how tension on the lever is controlled, because there's going to be a spring that goes against that nut, and we're not going to tighten it all the way down when we put it in. We're going to back it off just a little bit and leave us just a little bit of a gap in here, because this is where it sits. That tensioner is going to ride in right here, and you can see there's a groove where the ring will sit right there, and then there is a hexagon shaped slot that your nut is going to ride in. Alright, and this is the fun part. The back side of the lever, there is a nub, and that nub is what the spring holds onto. So you kind of almost have to do this all in one. Get your lever started with the hole over the motor drive shaft, slide it on, and as you're sliding it in, allow the tensioner and the nut to fall into place right there. And you can see if I hold the nut in place, and if I turn the screw one way, it's going to pull the nut back, which is going to relieve the tension on the spring and on the lever. And if I turn this the other way, it's pushing the nut forward, putting tension on that spring and the lever. Now, as I assemble this, I want to relieve all the pressure. Everything nice and a little bit of slack and everything as you assemble it. And I even have on my print an arrow with increased tension telling you which direction to turn that to increased tension. Handy dandy little note there. So, going forward, let me slide that out of the way. This is the heat sink for the E3D Aero Gold. This is what the filament rides through, and if you'll notice on the tip of this, there are two curves in it, slightly different shaped. Don't worry, this can only go in one direction, so you can't get the curves backwards. They're going to go in their appropriate position as long as this slides in correctly. You'll see the bottom of it square on part and round on the other side, so it can only go in one way. And this is some Capricorn PTFE tube. Having a perfectly square cut on your PTFE tube is extremely important, because if you don't, what will happen is you give room, once again, when you're using flexible tubing, and that's why we're putting a direct drive on this printer, is for using TPU. And anyhow, when using flexible tubing, you don't want any place for it to go. To get the right length, let me back this off. This is the throat that your filament is going to feed through, and it's threaded to screw up into that heatsink. And you'll notice it's got a wide bore right there with a lip down inside of it, and that's where your PTFE tube is going to sit. So to get the right length, you pretty much got to start with a guesstimate, and you want to guesstimate a little bit long. And I kind of like to keep, just for looks, I try to keep the end of the threads on the throat flush with the end of the heatsink, and then you'll have that slight gap, that standoff. But anyhow, you can see the shape where that tube is going to go through here and around the outside. It's shaped the same shape pretty much as the base of that. So it only goes one way. And when you go to slide it in, if you had it wrong way, you definitely know. So anyhow, go to screw this on. And as you can see, yeah, got to get it to pop into the socket and the throat there, or whatever you want to call it. And as I go to screw this down, it's going to want to push that out the top. So leave that just a little bit loose, and I've got one thread hanging out. The reason why is because when I put this all together, I want to be able to tighten that down to push against the ends of that PTFE tube to keep it to keep everything flush inside there, no gaps. So anyhow, using Capricorn tube, by the way, which has much better tolerances than your standard off-the-mill PTFE tube, less give for flexible tubing or flexible filament to be able to bend and bind inside the PTFE tube, which if you're using just your off-the-shelf PTFE tube, that can happen. And so you don't want to have that give. Alright, so you can see the grooves in the bottom of that housing. That's where all this is going to sit. And the hole in the middle goes over the drive shaft on the motor, and the hole in the top left of this is going to go over the drive shaft for your big drive gear, and then everything else will line up. So because I don't have a GoPro on my forehead or anything and a large tripod standing over top of this, just going to lay this like this, and you want to lay it flat when you're putting it on. Oh my goodness, that went together so beautifully smooth. And make sure, kind of wiggle everything, make sure everything's popped into its corresponding hole all the way. Give it that little wiggle. And I am seeing looks like my gaps are closed. I don't know why they leave gaps on the outside here. It's kind of deceiving. It makes you think it's not pushed down all the way, which it is. Once again, gap on the outside makes you think you don't have it down all the way. But look, it's all the way in. So, but for good measure, just double checking it. I feel like something is not lining up right though, so I am not afraid to triple check everything. Just feels like I have too much wobble. Alright, so everything is, it just feels like there's too much wobble, but anyhow, oh, while I'm showing you this, the round cuts on the top of this, you can see the purpose right there. They go right in between your gear that's driving the filament and your little pulley on your lever, and that is once again to not give your filament any room to escape when it's being forced down the throat of that tube. Okay, screws. Now with the kit, you're going to have what I believe offhand, I think this is only a 20 millimeter screw. You're going to have one that is a different size than your other screws. All the other ones are 30 millimeters. And you are going to have 3 holes that line up with 3 holes on your motor. The 4th hole in the motor you're not going to use. This hole is slightly off pattern, as you can see. So your shorter screw is going to go in that hole to hold the housing together. And you just want that snug. Don't over tighten it, because you are screwing it into plastic. Okay, now the 30 millimeter screws that they send you with this, I don't feel are long enough. They just barely grab the block of the motor. So I have some 35 millimeter screws, which are actually slightly too long and bottom out too early. So what I've done is put 3 millimeter washers right there, just little flat washers to get the spacing just perfect. 3 was the magic number to where the screw bottoms out completely in the motor as it's completely tightened and snugged down. And go ahead and pop those in each hole. And they are using a different size Allen wrench, which is a good thing, because if you have to disassemble this, you don't take out all of the screws. You only take out the screws you need, and the one that's holding the Aero Gold housing together is still in place. So you don't take out too many screws. So it's actually a good thing that they are using a different size Allen wrench. Now I could put a 20 millimeter in there that uses the same size because it's part of the same kit that I got these 35 millimeters out of. But I am intentionally leaving it a different size for that very reason. And then just get these snug. They're going into aluminum on your motor housing. Might actually be steel, but anyhow, point being, it's not like you're going to rip out plastic threads like you would with this one if you over tightened it. The fan comes with a Noctua fan. I wish they would change their color scheme from tan and brown, come up with something else. Is black really that hard? I understand they want to stand out with their own colors, but tan and brown gets old after a while. Oh, this is actually Phillips screws. Oh, by the way, let me demonstrate this. On the heatsink, there are little notches made in the heatsink for where your fan's going to go as I knock over my tripod. Little notches. And that's where your fan's going to mount. So, anyhow, I've already got the screws in the fan and ready. Tighten it down. Just snug. Alright. So that is the head assembly, print head assembly for the most part. This is still loose. We're not going to put those rollers on until you actually put this on the gimbal. Hook that up into the gimbal, put the other rollers on, tighten them in. Intentionally angled the fan so the wire is facing the back. The BL touch wire will go up here as well. Once again, cable management in mind, all the wires in the same place. And then this wire will be able to come over and cable management. The front of this is got a hole for a fan. Now I added these holes for a 40 millimeter fan, and they might be a hair off, which can actually be a good thing because it'll hold things a little tighter. But anyhow, for the most part, they're pretty well in place, dead on. And then you even have a set of holes on the outside that the original designer had put in this, which I believe accommodates a 60mm fan. You can put a squirrel cage fan on this that would suck air in the front and then pull down and blow through a shroud. I have designed my own shroud that is very basic. I might clean it up later, but if it's functional, I might just leave it alone. But anyhow, with a 40mm fan on it, it'll pull air, as long as you got the direction of the fan correct, pull air right through the backside, suck it in, push it into your fan shroud, and have that shroud blowing air, fan duct blowing air down on your parts down below. So that will be for your part fan. And then this fan does not cool your parts. This fan cools your heatsink. So, but anyhow, there's that in a nutshell. So, enjoy.